This knife is from Target. This knife is from Kroger. And this knife is from Walmart. Now, it'll chop a pear, it'll chop an apple, but we need something better than that. I know a guy. Let's go meet him. So we're here with John Phillips at Primeaux, his knife making shop.
Yep.
So what do you want to start with, man?
Yeah, so here we are. This is the forge. So this is kind of the first place that everything starts out. So we start with raw metal, what it looks like this or whatever, and we actually turn it into a layered steel. So these are all kind of pieces in progress. This is the forge. This is all homemade, as if you couldn't tell. This is a ribbon burner style forge. So inside of here, if you look, there's actually about 30 different little burners inside of there that each shoot out a flame. So essentially this forge can get, has a very hot and very even heat.
Was this one of the first pieces of equipment that you made when you first got into it?
No, actually this is about my 4th or 5th forge.
Oh wow, okay.
And they destroy themselves by nature.
Sure.
So there's just extreme heat. You know, this thing, the working temperature for this is around 2,000 degrees. And so, you know, once this thing gets hot, like, it gets really hot. And it's all powered by propane. So we have a propane tank over here. And then that goes into my own PID AI controller. So basically that means that I have an AI controller in here that controls the temperature of the forge.
Automatically?
Automatically.
Yeah, nice, okay.
So one issue that I used to have was burning up the steel, because you don't want to overheat the steel, because as you do heat the steel, the particles inside of it grow and they expand. And as those particles grow and expand, the metal is losing its carbon and it can actually start cracking and breaking, and the metal is breaking down. So keeping the temperature is very crucial.
Tell me about the almost filing cabinet looking situation here.
Yeah, this is just a filing cabinet.
It is?
I mean, a lot of the stuff that I make is made from metal that just I've found from around. I used to do a lot of scrapyard digging and go out to industrial scrapyards and just like picking up parts and pieces and things that I could use.
Sure, I mean, it sounds like the DIY mentality is very much a part of you.
Yeah, DIY is like huge. Yeah. Like I was in the punk rock when I was a kid, and like, you know, figuring it out has always been part of my, I don't know, part of my success, and part of the personality of my work, I think, comes through. You know, you can feel that kind of DIY aspect in the work. So anyway, yeah, like I was saying, this is an AI controller. So as the temperature of the forge comes up, it hits a target temperature, and then there's a solenoid here that turns the gas on and off. So it's pretty cool how it all works. So I have 2 of these forges, and so they're both basically the same thing. This one's a little less worn out, a little newer, and a lot of times I'll have both of them running at one time. So, you know, if I'm doing a big production run, I can work on like 4 or 5 things at one time without having to slow myself down. And so as the metal gets hot, then it goes into these machines here. So first of all, this is a 50-ton hydraulic press. So there's over 100,000 pounds of pressure between these 2 dies. And so basically the way this machine works is it gives a very slow and controlled squish. And so there are stops that I can set here that tell the machine where to start and stop. And then right now I just have flat dies, but basically this just gives a very slow, controlled squish, just like you see on like the hydraulic press channel or whatever.
Not a fast hammering.
Exactly.
Right.
However, if I need fast hammering, this is our power hammer. so basically it's a big air-powered hammer. And so this is about 200-pound hammer, and that's controlled by this pedal here. And you can see it has extreme control. I can really like dial it in, and you can imagine when I really put the pedal down, it really slams hard. And so this is able to replace a lot of the hand hammering work, because I'm not a big dude and I need as much mechanical advantage as I can have. And so since we're also running a commercial shop here, you know, I need big equipment so I can work quick. So that's why it's so big. And this is actually sitting on a 35,000-pound concrete slab. So we had to dig a hole 6 feet deep here and fill it full of solid concrete, just so that this hammer didn't smash a hole through the floor under it.
Okay.
So it's very, very serious. This is built on a design from the early 1900s. So the machine's brand new, or it's about 3 years old, but the technology itself is over 100 years old. So it's pretty cool that
and we have some
still works. Yep. And before I had either of these machines, this was my first hydraulic press I built. So I built this in my garage at home, and this is completely built out of scrap materials. From scratch.
Wow.
Like these are all things that I went digging through the junkyard and found. You know, I found a big metal column here. You know, I took some metal plate. I found this was a tractor hydraulic. I learned all about hydraulics and how hydraulic systems run. And basically, this machine has 84,000 pounds of pressure. So this is a 42-ton press. And I use this one. This one has a lot of custom dies that I've built. So basically, this will just squish things out, texture things. It's a very precise tool, despite how crude it looks. You know, I can really use it for some special stuff. So like if I'm making my Damascus steel, I have various texturing dies that I make that create different topographies in the steel. So it kind of just depends on how I want to contact the material.
Sure. And
yeah.
will you tell me a little bit about some of these pieces you have laying here?
So these are all just some knives that need reworking.
Okay.
They're kind of just waiting on the sidelines
Gotcha.
till I have time to deal with them.
Sure.
And then this is another machine that I built myself. This is called a rolling mill. And so basically this is like a pasta maker for metal. And so the way it works is I take a hot piece of metal, let me grab my tongs. So say this would be coming out of the forge, stick it in here, and I use the pressure of my foot with a mechanical advantage to then roll this piece out to the desired thickness. And so I can just keep on repeating this. As long as the metal is hot, it'll keep on stretching it out, stretching it out.
This lengthens the blade.
Exactly, yeah.
Gotcha.
Lengthens it and thins it out too. So, you know, we can hit very precise thicknesses. Because a good knife is a thin knife, basically. You know, or as far as kitchen knives go, like you want to not be wedging through your food. You want it to be moving very gracefully through the meat or vegetable.
Sure. Now, tell me a little bit about the advantages to building your own equipment versus buying something brand new.
Well, first of all, you can't always just buy something. Like, there's nobody that manufactures this machine.
Okay.
Like, there's literally nobody in the world that has something like this for sale. Because it's so niche that, like, not a lot of people need it. Or if they do, they're large industrial, you know,
so you would
steel
have to
mills.
contract out this to a big company to manufacture a product specifically for you?
Pretty much.
You build it yourself?
Yeah, basically.
Yeah.
Basically, there's not a lot of options. And, you know, before I had this machine, I had that machine because I was able to build this one for under $2,000. And, you know, this one's almost, you know, $20,000 put in. So, you know, it's a huge, huge difference.
Sure.
And also, I just enjoy building stuff. Like, the challenge of figuring these things out is really exciting. and to like take something from like a pile of junk into like a useful object. It's really cool. It's a very gratifying experience.
Yeah, I guess in my mind I would be thinking about, okay, John is just getting started into knife making, and my mind goes to the process of making the knife. But you had to first figure out, no, I need to build the machines to then make the knives.
Well, it took me a while to get there.
Okay.
You know, like I started off by just hammering stuff by hand, and like man, this is really hard, and my shoulder hurts, and you know, like by the time I'm done hammering out one knife by hand, like I don't want to make another knife. You know, I'm just done with it. Mm-hmm. So figuring out how to make things easier and faster has kind of always been part of my way of thinking, I guess.
Yeah, sure.
And a lot of that goes back to that job that I had back when I was in college, where you know I was having to figure out these kind of production engineering aspects, and I was having to build a lot of different tools and machines to like do a task, and I saw the impact that had in the process. And so like the process is really important to me, and like how things move through the process is really important. So this is the forge, like I said, and then after, well, then of course we have the classic anvil.
Yeah.
And this is, you know, we still use the anvil and a hammer for kind of tuning things up. And so I'll use the hammer and anvil at like either the beginning or the end of the process, but it's pretty crucial and it's pretty cool. This one's from the early 1900s, and it's a Swedish anvil.
So machines can't always replace the...
Yeah, you know, there's just like fine tuning that, you know, you just have to use your eye, and that's all there is to it. And
Sure.
you know, I have a whole rack of hammers and tongs and all kinds of hand working tools here that I use, you know, whenever I forge. So yeah, after everything gets forged, then the next step is called the heat treatment. So that's where we actually start to convert the structure, the molecular structure of the metal, from one stage to the next, where we're going to take it from just a piece of metal into something that can hold an edge and something that's hard and flexible. And so that's what we have these two kilns over here for. And I've got all these knives hanging up here that are all getting ready for heat treatment. And so what's involved with that is heating them up to a very specific temperature. And every type of metal has a different target temperature it has to be heated up to. And then it needs to be held at that temperature for a specific amount of time. So all these are going to be heated up to about 2,000 degrees. And then they're going to be held there for about 20 minutes. And then they have to be what's called quenched, which quenching is the process of quickly cooling the metal. And so we have two different ways that we cool the metal. Okay. We either dip the knives into a container of oil. So we take the hot knife out of the forge or out of the kiln, and then we dunk it into this bath of oil here. And this is a special oil that is specifically designed for metal, and it's specifically designed at a viscosity that cools the metal in a specific amount of time. Pretty far out stuff. Or we use an air quench system. So I'm gonna have to set this up for you.
Okay.
It's pretty cool. So this is another piece of equipment that we designed and built here. Essentially, these are used for specific metals that require what's called an air quench. So that means we'll pull it out of the kiln at the 2,000 degrees or so, and then we have to use air instead of oil to cool it at a different rate. So we're trying to cool it down within about 30 seconds to a minute, versus this is cooling it down in like 3 seconds to 10 seconds. So I'm going to hook some air up to this and show you how it works. So this is another piece of equipment that just doesn't exist, and I don't know anybody else that has one. But basically we pull the hot knife out of the kiln, and then we throw it in here, and then we push this button that slams those plates down, and these plates have cold water running through them, so they stay nice and cool. And then we turn on a valve, and this is blowing air through the passage, and so it's evacuating all that hot air, and so it's cooling the knife very quickly, but not too quick. And then when it's done, we take it out, and it's a hardened blade.
And is this a process that you came up with?
The air quenching is like an industry standard process, but typically what people will do is just clamp their knife in between a vise like this, and they'll just spray air on it and let it cool that way. But we started getting into processes where we were doing like 300 knives at a time, say, and you can't do like 300 knives that way because this vise ends up getting really hot after, you know, you've clamped like 10 knives into it. And so we had to figure out a way that we could just do bigger batches. So this is what we came up with. So it's a pretty cool piece of equipment that not a lot of people appreciate, but we do.
How many years did you go without this machine until you realized I just need to build something like this?
About 3 years.
Yeah.
So yeah, we did about 3 years worth of knives, and then it wasn't until we moved into this space out of my home garage to where you know, I started focusing on scaling the processes up more, that, you know, we started running into issues where, you know, there were bottlenecks being created in the process, and so we had to find solutions for that. So then after things get hardened, then they go into this oven here, and this is called the tempering oven. So after we heat it up to that 2,000 degrees, we cool it down really quickly, and then we need to relieve the stress from the knife because we basically like just shocked that metal. We've changed the molecular structure inside of the metal, and so now the metal is like super brittle and really, really hard. So now we need to soften it up. So that's called tempering. And so that's what this oven's for. And so we'll temper it at about 350 degrees. And so it cooks in there for a few hours. And then we take it out of there. And then the knives need to go into liquid nitrogen. So that's empty right now. But basically we'll take that knife and then we'll soak it in liquid nitrogen. And we'll bring it down to like negative 350 degrees. And so that completes a molecular change within the steel, to where the molecules literally like flip inside out on themselves. It's pretty far out. And so by doing that, the knife then becomes very flexible. And so it'll bend and return back to its shape.
And then it's ready to be...
Then it's ready to be ground.
Okay.
So from there, we'll go to the grinding room. So this is the grinding room. And basically, I have 3 grinders here. And these are called KMG grinders, which stands for knife making grinder. And each of them has interchangeable arms. And so I have a whole bunch of different arms that, you know, if I need to contact the metal with a large wheel, I can. Or if I need to contact the metal with a little tiny wheel, I can. If I need a flat thing, I got that. If I need another flat thing, I got that. Basically, there's just lots of different ways that you need to be able to manipulate the metal in order to create the bevels on it. So let's see. We start off with like a very, very rough belt. So you can see this here, this is about a 40 grit. And so this is very, very sharp. And this is where we start grinding. And then we bring it all the way up to, let's see, we bring it up to about an 800 finish, which is, I wouldn't say it's like notebook paper, but it's pretty smooth. And so then after we've ground it here, then it goes over to the disc grinder, where then we bring it up to about 2,500 grit. So we bring the knife all the way from, you know, a freshly forged finish all the way up to like a polished finish.
And could you show me an example of how you would hold the knife on either?
Yeah. So essentially, turn it on, and then the knife just gets slowly ground. So obviously that was just a second of grinding, but it takes about an hour of grinding to work up through all the different grits. So yeah, and then basically at that point, the knife is pretty much where we want it to be as far as like a finished blade. And so then it's ready to start getting assembled. You know, by that point, the blades are more or less at one of these stages. And so these still have finishing steps that have been applied to them. But basically, they're just raw blades by the time they come out of the grinding room. And so this is an example of a Damascus blade, and this is an example of what we call a mono steel blade. So this one's made with multiple alloys, and this is a single alloy. So over here, this is our machine shop, so to speak. Drill press, mill, surface grinder, and we got a lathe over there. Little bandsaw. Mm-hmm. And so basically you can see all these are old tools that I picked up at auctions, Craigslist, you know, that type of stuff. And then this is our wood shop. So I try to keep the metalwork and the woodwork somewhat separate. Yeah. Keeping the dust separated is really handy. So table saw, chop saw, and then our wood. And so we start with wood that comes in all different states. So we work with a lot of burl woods. So basically these are like diseases in trees that form really interesting grain formations inside of them. And so you cut it open and it might look like something like this. And we work with lots of different species of wood. Here's a big piece of burl wood here. You know, we'll start from lots of different states. And then we take and we cut everything down into a usable block. And so from there, we put all the wood through a stabilization process. And so that means that basically we suck all the air out of the wood in a vacuum chamber with a vacuum pump going on. And meanwhile, the wood is submerged into a special resin. And that resin gets sucked into the pores of the wood as we pull all the air out. And then we release the vacuum and it just penetrates even deeper. And so then we can take that piece of wood that's been sitting in the resin and we put it into an oven wrapped in aluminum foil, and it essentially plasticizes the wood from the inside. And so like you can feel these different pieces of wood here and like how they weigh different amounts. Like that
this one's much heavier.
Yeah, and that one's like pretty light because we've filled all the pores in this with a resin. And so that means we don't need to use any special finishes on the wood. We can basically just polish it to a finish. And you know, there's no polyurethane to wear off. There's no weird...
Because the finish is within every single tiny little pore of the wood.
Exactly, it's in the capillaries of the wood.
Yeah, okay. And
so within that, we're even able to add dye to the process, so we can make wood like almost any color that we want. So I've got like blue, I've got green wood, and like even sometimes we can get different effects, make it stripy or whatever, just depending on how we place it into the resin.
And I know sometimes in this process you'll add pieces from the customer that are maybe something sentimental.
Yeah, absolutely, right? Yeah. So, you know, we've used special trees that fell on the family farm, or like, you know, grandpa's shotgun, or, you know, like we can pretty much apply this process to about any wood. So that's really cool that we can like customize things in that way.
Do you ever melt down anything to include into the blade as well? Would it have to be steel or?
No, it doesn't have to be steel.
Like a piece of jewelry or something?
I can, yeah. I've incorporated somebody's father's ashes into a blade. And so like while we're forging the knife, you know, he brought ashes and we like hammered ashes into the steel. We've done coins, car parts from like, you know, an old Harley or an old like Model T. Yeah, there's lots of different stuff. So any way that I can incorporate a story into the piece is a bonus for sure. So then after we have everything stabilized, then it all goes to the CNC machine here. So this is a special purpose-built robot, essentially, that we use to carve our handles, and so that everything fits together just perfectly. You know, since we're creating semi-production knives, you know, every piece is custom, every piece is unique, but yet within the Primeaux brand, we want there to be a level of consistency. And so this way we can guarantee that every handle has the same profile, the same handle feel, the same fit, you know, all that stuff. And so this is a machine that we also built ourselves. And so it's on the 4th or 5th different iteration. And so anybody that knows about CNC machines knows that there's different ways to drive them, and there's different ways to control the accuracy. So, you know, we started off with a belt-driven machine. Now we have a ball and screw style. We have, you know, sealed cartridges on it, limit switches, and we have a 4th axis here. So that basically means that we can create off-center turnings, because the head will move left, right, up, and down, and then this piece will also move, spinning the piece around, if that makes sense.
Like a lathe?
Like a lathe, except a lathe only works off of a center line. But because this can move left, right, up, and down, we can create round things, but they are not necessarily on center. And so it makes our handles really unique because they can't really be manufactured on a lathe because of the shape of them. And then once we have all the components together, this area over here is also kind of our assembly station. So like I was saying, here's some examples of handles that we have in process. And you can see how it's like, it's not round, it's not centered, it's not symmetrical, you know, except for down that way. This is another example of a handle that we made. So this is using a ball nose bit, and it creates these grooves in it that give a cool texture.
And a better grip, looks like.
Yeah, yeah. So these are just some new things that we're working on. And so once the pieces make it over here, the handles, basically they need some sanding to be finished. You know, they come off the machine like not rough, but not finished. And so then the handles go back in the grinding room. They get sanded as well. And so everything gets sanded up to a nice mirror polish. Not mirror, but nice and glossy, shiny. Here's some of those handles finished. So you can see the example of like how shiny it gets after it gets sent through the different sanding stages. These are all parts in process. So then pieces come over here. This is kind of where I do a lot of the small handiwork. You know, I've got my magnifying glass and my light here.
So this is for a lot of detail work.
Yeah, there's a lot of detail work. This is a Fordham tool, so it's like a Dremel tool that I use to kind of make sure that things fit up just perfectly. And you can see a bunch of my parts that we've been through and parts in progress, various weird stuff. So that brings us to the next component of the knife, which is the bolster. So this is the other like thing that's really signature about Primeaux Knives, and this is the part that that you grab when you pick up the knife. Mm-hmm. And this component right here, it's called the bolster. And this took us about 2 years to design. We went through literally thousands of different versions before we found like the one that we wanted.
And you're looking for just the right feel in your hand?
Yeah, the right feel, the right proportions. I don't have my bad ones in here, but you know, we 3D printed like
Yeah.
hundreds and hundreds of these to just figure out exactly like how long it needs to be, like how deep it needs to be. This was one of the first 3D prints that we came to a consensus on. We really liked. And I've been kind of keeping a small catalog of all the different versions of these things that we've made, you know, casting them in different ways, 3D printing, different milling, different alloys. It's a really cool alloy here. It's called gem bronze. You know, this is a 3D printed wax version that then we can take and make a bronze version of. So our whole first production run, we did entirely this way, where we 3D printed them and then cast that 3D print into bronze, all right here. So it was very time consuming.
Now, tell me, why was the bolster such an important piece to really take so much time to figure out exactly?
I wanted to create a design, a handle design that was distinguishable across the room. And I wanted to create something that encouraged the user to have good ergonomic use and encouraged the user to have a safer experience with holding a knife. So I saw a video of like one of the Kardashians trying to cut something like this. And anybody who's ever used a kitchen knife before knows that, you know, you're supposed to hold the knife in a pinch grip fashion. And so this bolster just kind of guides your hand up into that nice position. You know, that's where you make the contact with the knife. And so it needed to provide a counterweight, it needed to be comfortable, and it needed to be stylish. So, you know, I want to have kind of like an Art Deco look to it. I want to have a timeless look to it. And so in order for things to have that kind of timeless look, like you got to go through, you got to strip away a lot of details in order to like reveal the true essence of the thing and to like, you know, create something that's like really nice and simple and well designed. And it's amazingly hard to like figure out how to strip away everything and make that work.
And now the bolster is, what material is it usually made from?
So we either make them from bronze or aluminum. And so the bronze has a little bit more weight to it and kind of this old world aesthetic, and then the aluminum is much more lightweight and has a little more modern aesthetic to it. Mm-hmm. And so the aluminum is also cool because we can anodize it a lot of different colors. And so, you know, we can make them blue or purple or black or red or, you know, these are just a few of the colors. Even this is a gold anodized that, you know, you can see is different from actual bronze, but similar but different.
And the handles, let's go back to that real quick.
Yeah.
We talked about wood. Is there any other material that you use for handles?
Yeah, so this is a cool material. This is called fordite, and this is actually car paint. So in the factory, in the car factories, where they paint the cars, they have big robots that just go through and spray everything. And these robots, they spray over the cars, and eventually the paint starts to collect on the walls. The paint collects on everything. And so it starts to form these like sheets. And so you can see in here, like every one of those is a different color of paint. And so what people have done is gone into these car factories and chiseled this stuff off the walls, and they sell it. And so basically I buy it off eBay, or I have a dealer that specializes in sourcing these exotic materials.
Was that an aha moment for you when you discovered this?
Somewhat. You know, I had seen it for a while and was like, what is that stuff? How do you get it? Like, what makes it so weird? And then I found somebody that had it for sale and bought some of it, and pretty much immediately like fell in love with it. Like, it's just such a cool material. And so the way we make these handles is by laminating a whole bunch of this stuff together and kind of building our own thicker chunks of it essentially, and then milling that down. And then as you mill it down, it reveals all those colors and textures. We also work with fiberglass. So this is actually a material called G10. That's an electrical insulator. That's really cool. And it has a very like sturdy, like hard feel to it. And it's waterproof, it's shatterproof. So it's a very, very durable material. And we can mill that on our machine back there as well if we want to.
And then let's talk about some of the textures on the blades.
Yeah.
That seems to be, there's a variety of that here.
Yeah, so textures are really cool. And depending on what I'm going for, I can create a lot of different patterns and textures based on how I layer the metals and how I forge them and what metals I use. So like, you know, even between these 5 knives here, these are all different types of metal, all different types of finish, all different types of forging processes. So basically I manipulated these steels in different ways throughout the process to get different effects. Kind of just depending on what I'm trying to get. And so like this one is what they call a dog star pattern. This is a twisted pattern. And so this one has low layers. So, you know, this piece was maybe like a 20-some layers of Damascus. This one is like 200 layers of Damascus. And so the more layers you have, the more dense the pattern gets. And then the more you manipulate the patterns, the more busy they get. So this one right here, for instance, this is supposed to look like a Viking ship. It's what that pattern is supposed to be reminiscent of.
Looks like a wood grain.
Exactly.
Yeah.
Yeah, so basically this was just forged out with all those layers just sitting nicely on top of each other with like not much manipulation in the process. This one, we forged out the bar of steel and then we twisted it and we twisted and we twisted it like a towel, like you're wringing out a towel basically. And then when it gets ground, that's the pattern's revealed.
So there's some similarities there with glass blowing as well.
Yeah, absolutely. Yeah. Anytime, you know, you're working with materials that you're bringing up to a state of plasticity, there's a lot of overlap. So yeah, glass and metal definitely are intermeshed in their processes. And then if I want just a real simple finish like this, that's called a stone wash finish. And so that basically we achieve by literally shaking the knife around with a bunch of rocks. I can show you how that one works real quick. So over here, this is our tumbler. And so basically, and eventually it'll come back out.
Okay.
So we shake the knives around in this bin full of soup and rocks, basically. There's a special soap in here that's made with like coconut oil and some other stuff that prevents the metals from oxidizing while they're in here. And then each one of these little rocks is a special ceramic stone that has special polymers in it. So it doesn't remove any material from the knife. It just kind of lightly abrades it. And so that's how we get that stone wash finish.
Style, what is this?
Yeah, so this is just another form of Damascus steel. This is one of my older pieces. This is made with a carbon steel. And so again, just depending on how I forge the metal, what types of metal that I use, what types of acids that I use to reveal the patterns. And so after the knives are forged and polished and everything, in order to bring these patterns out, we have to do a special bath of acid where we soak the knives in either a hydrochloric acid or a ferric chloride. And so basically those react with certain things in the metals to then pull out the patterns. And I'll typically do that in like a big batch. And so yeah, these are some older pieces, and these are some newer pieces.
Now you pulled this one out here to show me.
Yeah, so this is a cool piece. This is a gift that I made for a friend of mine who recently retired. And these are all stones that he got from his mother's collection of things. And he actually helped me forge the steel out as well. So I don't really make stuff like this. This is the first dagger type knife that I ever made. But it's just a really fun thing to make. And it's cool that I can like create pieces that are artistic as well as functional. So and then this.
Will you show me what is more standard, like what you make a lot of?
Typically, you know, chef's knives are our specialty. So something like these are our specialty that we kind of keep going through our production processes. And then occasionally I'll get to make a piece like this or like this that are more more creative and less functional, more aesthetic. You know, they're totally usable things, but I think more often than not they're showpieces. And then I also do some leather work. So this is the sheath for this big Bowie knife that I'm pretty pumped about. So this is stingray belly. You know, it's all hand stitched. This took me way too long to make. But you know, it's really cool to be able to like do the whole package.
Yeah, sure. And then sometimes you'll make smaller knives, like petty knives, paring knives, and then I see the mini cleaver there. It looks like, right?
Yeah,
is that what it's called?
Yeah, I've got this mini. This is one of my older mini cleavers. It's a really fun knife just to have around. You know, cleaver is not really a tool that's used in the kitchen anymore, like it used to be way back in the day when you had to butcher your own meat. But the mini cleaver is cool because it's less to hang on to, and it's just a fun little knife to use. Yeah, here's a sword that I started forging out. So this is only the second or third sword that I've forged. The first one I forged was on Forged in Fire. So that was a TV show I did in 2019 where I made a sword that cut bullets and did a bunch of other crazy stuff. So this is a Damascus sword. So you actually can't see the pattern in it, but you might be able to, I'm not sure the camera will pick it up, but you can kind of see the lines through the sword there. And so after I finish grinding this, I'm going to grind a fuller into it, which is like a slot, a shallow slot. I'll cut the bevels onto it, and then it'll have to go through an etching process. So that's where I'll take the pattern from looking like this, and then it's going to look more like this when it's done. Here's another knife that's kind of in process. This is actually the one that I forged when Ryan was here. And you can see how far behind I am. I haven't had time to do anything since then. But this is called an integral bolster. So this is where I actually forged this component into the knife.
And why did you do that for this piece?
Just sometimes I like to torture myself. Creating an integral bolster is one of the most difficult types of chef's knives that you can make, just because it's very hard to manipulate the material in such a unbalanced kind of way, where like you can't undo any of your movements. You know, once you do something, then it's done. There's no backtracking. Whereas when I make a knife out of a flat piece of metal, you know, I'm starting off with something like this, and there are different opportunities along the way to course correct.
Yeah, you have a backspace button, you have an eraser.
Yeah, somewhat. And so it's a lot easier than just going all for it at once. Here's some examples of what the Damascus looks like. This is one that I etched. As you can see all those layers in there, it's pretty cool. And so basically this knife will end up, this chunk of metal will end up turning into something like this, which is pretty far out.
Wow, yeah, it's amazing to see the beginnings.
This is another one.
The finished product.
So this is the same. This is the same thing as this, but this one I etched in acid to reveal those layers. This one's straight out of the forge. And so basically one of these will get one knife. And you know, by the time that they've reached this point, there's a few hours worth of work that go into it just to make the material.
How many hours go into one knife typically?
Typically, I would say 10 to 20, but often it's 20 to 100.
Okay, so there's a range there.
Yeah, it's a huge range.
Low end, 20 hours, high end, 100 hours?
Yeah.
Wow.
Yeah. Yeah, I just sent out some pieces yesterday or last week that I had several hundred hours in too. You know, by the time I made very complicated patterns in Damascus, by the time I made a custom solid silver bolster, you know, it just really adds up quick.
Is there anything else in the shop that you want to look at?
Sure. So the final stage is sharpening, and that's something that everybody asks about. This is the sharpening station over here. You can come check out. So basically, I work mostly on wet grinding stones, but we also have a variety of other types of stones. And so just depending on exactly what I'm trying to sharpen, you know, most of my kitchen blades I put on here, and these create a really nice slight hollow grind. So basically the curvature of the wheels kind of create an edge that does this kind of, you know, V, instead of being a hard V that stone creates.
It's a curve.
It's a slight curve.
Slight curve to it.
So it gets a really, really sharp edge, basically.
Okay.
By having that hollow edge. But you know, a lot of times I still just use like natural stones. So this is just literally a piece of rock that's nice and flat, and I can get a really, really sharp edge with it. Just depending on what type of metal it is, what type of knife it is, all that business.
All of these different types of materials, these are all different?
Yeah, they're all different. Different hardnesses, different grit sizes, different materials. So, you know, some are synthetic. So like this one here I really like, but it's completely synthetic stone. So, you know, I'm sure it has some natural grits in it, but it's binders and things like that make it work. You know, really, really, really rough stones. You know, if trying to sharpen a lawnmower blade or something. We have diamond stones. So this is a piece of metal that has a diamond coating on it. And so instead of using natural stones, it's actually diamonds, so it wears less quickly. Have little tiny grinding stones for like if I need to get into something. So really just any way possible that you could imagine, we figured out how to sharpen stuff with it.
Is sharpening the final stage?
Yep.
Yeah.
Yep. So once everything's sharpened, then it's ready to box up and ship out.
Oh, nice. Okay. This is the biggest knife you've ever made right here?
Yep. This is the biggest knife I made. My son and I made this on a snow day back last winter when we needed some color in the shop, you know. Everything was gray out, and I had some strip of lighting around. I had a piece of metal sitting around and a little extra time. So yeah, by the time everything goes through all these different processes, you know, then the knive's either ready to come up here in the showcase or it's ready to ship. So, you know, I think these are some really cool pieces here that, you know, are like super modern looking, and it's pretty wild to know that like that was all made right here with these tools. You know, with the platform, we're able to create a lot of different looks, different aesthetics.
Very cool, John. Thanks for showing us your shop, man.
Yeah, dude.